In today's video, we'll start with Chapter 1 in Class 9 Mathematics of CBSE. Chapter 1 is called Number Systems. In this video, we'll be covering 1.1, that is the introduction. In this, we have the number line, the rational and irrational numbers, and also the method for finding numbers between two different rational numbers. That is, how to find rational numbers between two numbers. Starting with the number line. A typical number line, as you might have seen before, looks something like this. So in between there's a 0, we have some numbers on the right hand side, some numbers on the left hand side. And as we know, we have infinite numbers. So the positive numbers like 1, 2, 3, 4, so on till infinity. On the left side, we usually write the negative numbers minus 1, 2, 3, 4, so on till infinity. Now this number line is nothing but a tool which we use to represent various types of numbers. What are these types of numbers? So to understand the counting numbers, for example, we start counting from 1 usually. So 1, 2, 3, 4, so on. These are called the natural numbers and we represent them using the alphabet N. Now bear in mind that these natural numbers start from 1 and these are all positive numbers. If we include the 0 in these natural numbers, then we call them as whole numbers and we represent it as W. So all these are the positive numbers. Now what do we call these numbers when we include the negative numbers? So natural numbers, whole numbers, as well as these negative digits that you see here, all of these together on this number line are called integers. Now these are the three common types of numbers and how we distinguish on the number line. If we try to zoom in, that is, if we try to see just between 0 and 1, we can notice that there are the numbers which also go to infinity. Like between 0 and 1, we have numbers such as 1 by 4, 1 by 2 and 3/4, like we say quarter, half, 3/4 for example, and there are even more fractions. And these fractions, for example, like 1 by 2 can also be written as 0.5, right? This 0.5 is nothing but a decimal expansion. We'll discuss decimal expansion in further videos, but what we need to remember is that between these two numbers as well, we have a lot of numbers which can be written in terms of fractions. Now a fraction is nothing but a number that can be written in the form of p by q, where q is not equal to 0 and both p and q can be any of these integers. So when we include these fractions as well as decimals on the number line along with integers and the other numbers we just saw, all these numbers together are called real numbers and are represented by R. Now these real numbers can be classified as rational and irrational numbers. Let's see and understand what is the difference between these rational and irrational numbers and what qualifies a number to be a rational or an irrational number. So we have some criteria that needs to be fulfilled for a number to be rational number. For example, the first criteria is that it has to be in the p by q form, where p is any integer and q is also any integer, but it cannot be equal to 0. All integers are rational numbers. For example, we know that plus 4 is an integer. How can we write plus 4 as a fraction? You can write 4 by 1. So 4 is also a rational number and is also an integer. Now these rational numbers can be expressed as fractions or decimals. For example, 3 by 2, which also can be written as 1.5 when we write it in a decimal pattern. However, when you convert these fractions to decimals, they can be recurring in a pattern. For example, 1 by 3, we get 0.3333 so on, whereas this 3 is a repeating one. So when the 3 is repeating, we say that it is recurring in a pattern. So many decimals can be in a recurring pattern and they are called rational numbers. Now what is an irrational number? It's just the opposite of a rational number. We can write rational number in the p by q form, right? So irrational number is the number that you cannot write in p by q form. For example, when you want to find the value of a number such as square root of 2, we get a number which is 1.414278 so on. So you cannot write this number in the p by q form. It is a decimal that is non-terminating and non-recurring. That you can see here we had a recurring pattern where 3 is repeating. However, in this there is no pattern and it is not even terminating. So we call these types of numbers as irrational numbers. Some examples of irrational numbers include pi, which we know is 3.1415 so on, and under root 3 also, for example, is written as 1.73205008 so on. So these kind of numbers which cannot be terminating or recurring in their decimal expansions are called irrational numbers, and they cannot be expressed in the p by q form such as rational numbers. Let's start with some of the exercise questions in our textbook. So in exercise 1.1, based on what we studied so far, we have some questions. The first question is 0 a rational number? Can you write it in the form of p by q, where p and q are integers and q is not equal to 0? We know that this is the condition for a number to be a rational number, as we just discussed. So can we write 0 in that form? If you guessed yes, you are right. So yes, 0 is a rational number. For example, if p equals to 0 and q equals to 2, then p by q would be 0 by 2 and we would get 0. So we could write this. So anything divided by 0 would be 0. For example, I can write 0 by 9 equals to 0, 0 by minus 10 will be also be 0. So I am able to write in the p by q form where q is not equal to 0 and p is 0. As long as p is 0, you can write it as a rational number. So the answer for that will be yes. The second question asks us to find 6 rational numbers between 3 and 4. Let's see the steps you have to follow in order to find rational numbers between any two numbers. So the first step is that you need to convert these numbers into fractions. As we discussed earlier, any integer or a whole number or a natural number, for example, can be written as a fraction by putting the denominator as 1. So you can convert 3 and 4 into fractions and write them as 3 by 1 and 4 by 1. Now remember that we need 6 rational numbers between 3 and 4. So the second step is to choose a common denominator. It is better to choose a number higher than the number of numbers that you need, because we need 7. You can choose a common denominator as 7. Now in order to convert these two fractions to have the denominator of 7, you need to multiply and divide by 7. So 3 into 7 by 7, 4 into 7 by 7 will give us 21 by 7 and 28 by 7. Now the final step is to write the fractions between these two numbers. Now you will have 6 fractions between these two numbers, which are nothing but 22 by 7, 23 by 7, 24 by 7, 25, 26 and 27 by 7. So this is how you find rational numbers between two given numbers. Moving on to the next question in exercise 1.1, and they ask us to find 5 rational numbers between 3 by 5 and 4 by 5. As we can see, 3 by 5 and 4 by 5 are already in fraction form. So how do we find rational numbers between these two? Step 1 is to convert these fractions to get a common denominator that is higher than the numbers we need. So we need 5 numbers. Let us use 10 for example. It is easy to use 10 because it is easy to multiply and divide by numbers such as 10, 100 and so on. We need 5 rational numbers, so it is better to use 10. Now when we multiply and divide by 10, these two fractions become 30 by 50 and 40 by 50. The second step is to write the 5 fractions between 30 by 50 and 40 by 50. What are they? So 31, 32, 33, 34 and 35, and they all have common denominator as 50. So these are our 5 fractions between 3 by 5 and 4 by 5. In the last question of exercise 1.1, we have some true or false questions. Well, the first one asks us if every natural number is a whole number. So in order to address these questions, it is better to recollect our number line And also what we learned in the number line and the difference between rational and irrational numbers can be expressed using a Venn diagram such as this one. As you can see here, natural numbers are all the numbers that are positive and above 0. Whole numbers include natural numbers along with 0. Integers include negative and positive numbers along with 0. Rational numbers, which are represented by Q here, include fractions as well as other natural whole numbers and integers. Irrational numbers, on the other hand, are the numbers which cannot be written in P by Q form, either positive or negative, and both these irrational and rational numbers together form real numbers. That is, on our number line, any number that you can point on the number line is going to be a real number. Now with this knowledge, it would be so easy for us to answer these questions. The first question is, every natural number is a whole number. So natural numbers, as we can see here, are a part of whole numbers. So this is true. The first answer would be true. Now what about the second one? Every integer is a whole number. So integers have more numbers than the whole numbers here, as we can see. Whole numbers do not have negative numbers where integers do. So whole numbers are integers, but not every integer is a whole number. So the answer would be false. Now the last one, every rational number is a whole number. See, we can see that rational number consists of integers, whole numbers and natural numbers, but not all whole numbers are rational numbers. So according to this logic, whole number can be a rational number, but not every rational number can be a whole number. So the answer is false. That's the end of 1.1 chapter 1.